Hi, thanks for passing this on, and thanks for putting on this Airflow Summit. This is a great tool. I appreciate it, and hopefully I can give a little bit back to the community. What we're going to talk about today is using Airflow to speed up data-intensive tools. And what that means is we're going to use Airflow to bootstrap some application that was built recently at One Medical, and we're going to talk about that process and hopefully inspire maybe the community to do something similar the same. So the purpose of this talk is to demonstrate how Airflow could help you build new tools and hopefully inspire others to do the same. A little bit about myself. I'm a data engineer at One Medical, formerly from LinkedIn, Chegg, and MySpace. I know I've kind of dated myself by saying I worked at MySpace, but I've been doing this for quite a while. Probably wrote more SQL than should be legally allowed. And I've been using Airflow full time for about 2 to 3 years by this point. It's a great tool. So what are we going to cover in this talk? So first off, we're going to talk about this application that was created to detect data anomalies. We're going to talk about the architecture of this tool, and as well as how this tool communicates with Airflow. And in addition to that, how Airflow could decrease the cost to develop similar tools. So first, setting up the problem. So at One Medical, we consume and create a lot of data. I'd say that we have a data complexity problem, not so much a data volume problem, which is to say that we don't have to deal with large volumes of data, but we do have to deal with lots of complex data that's coming our ways. At One Medical, we have I'm guessing around 100 offices within the United States. We have a staff of hundreds of different doctors, hundreds of thousands of different patients. We communicate with lots of hospitals. And in doing so, we have a lot of information that we're consuming. That's everything from faxes, OCR faxes, to structured data. And so what you want to do is you want to create a tool that can find the bad data before it's passed on to analysts. And we're also lazy engineers. As Bill Gates has famously said, choose a lazy person to do a hard job because a lazy person will find an easy way to do it. So in the context of this talk, what we're going to be discussing is this tool that was built called the Data Anomaly Detector. I've affectionately referred to as the DAD tool. And so some things we need to make this work is we need to detect abnormal data, first and foremost. We need to scale to thousands of tables and columns. At One Medical, we consume maybe a dozen different databases. Those databases have hundreds of tables. Those tables have hundreds of columns. And so the scale that we have to work with, while not a huge volume, can be quite complex. And the cost to develop the tool should be minimized. We don't want more. And moving on. So what is needed to make this work? Well, the ability to do statistical analysis, storage to persist data and test results, a UI UX to manage the tool, create tests, and analyze the results. Database interoperability. We need the ability to extract data from our databases. Before doing that, we have to authenticate with them. We need the ability to run thousands of tests per day. Like I said previously, we have a complex data environment. And lastly, we need this to be secure. An interesting aspect of One Medical is we operate in the healthcare industry, which means that we have to operate within regulations that are set a higher bar than say many other industries. We have to pay extra money for servers that encrypt communication back and forth. We have a staff that's generally larger than most companies to make sure that our security is on par with industry standards for healthcare. In addition to that, we're also a public company. So security is a primary concern for us always. And also, the security team likes to say no when you try and introduce new technologies. And so it's important for people like ourselves, like developers, to be very careful about what we do when we're introducing new technologies to our environment. So in order to accomplish these things, we need the ability to do statistical analysis. For that, we're going to be using Python. The ability to store or persist data and test results, we're going to use MySQL. We need a front end for the users, so we're going to use Flask. So far, we've kind of described Airflow. And for everything else, we're going to be using Airflow for database interoperability, scheduling and parallelization, and it's got to be secure. One of the convenient aspects of One Medical is we already use Airflow within One Medical to process our ETL jobs. And so, it's already passed our security audits. And so there was no extra cost, at least for myself, to bring Airflow into the conversation to create this new tool. So what I'd like to talk about next is a bit about the architecture of this tool. And then we're going to go into some of the aspects of how this tool integrates with Airflow, and then wrap up the conversation about some of the wins that we've accomplished by integrating this tool with Airflow itself. So a bit of background about data anomaly detection in this tool is it's a complicated process that's worthy of its own talk to talk about statistical analysis. For this purposes, I'm going to be a bit hand wavy in the discussions about the statistical aspects of this tool. I'll be available for questions answers if somebody has questions after this talk. Generally speaking, to set up this problem, we have different services that are needed to accomplish our goals, and those being table settings. We need to understand where data is coming from. In the case of this tool, it will actually scan the information schema of various database sources, and so it collects that information to put to the tool and make available to the user. We need test settings. Test settings with respect to what type of test are we running and where is it going to run. For example, if we're analyzing some time series data, you might want to do statistical detection to see if the data point that we're analyzing falls outside some standard deviations of the mean. We have a data collection process. The data collection process is actually quite complicated. And the purpose of the data collection process is to collect data that goes into experiments and control groups. And for that information that isn't available in the talk itself, the data collection service will go out and pull that information and bring it into the data tool. Then lastly, we need the ability to analyze our data. And on top of this, we have a UI UX framework that allows users to interact with this tool. So that sets up the tool itself. The important part, at least for this talk, is what is it doing with Airflow? So far, we've talked about what this tool does to, at least from the user perspective, to define tests and apply that data, but we haven't talked about how that data actually is being consumed and how that flow of data is being moved throughout this process. And that's when Airflow comes in. In this case, the data tool uses Airflow as a service in the backend to accomplish these kind of things, to communicate with the different databases that are set up through Airflow and bring it back into the data tool. And there's a process that we're going to go through specifically about how this is enabled. And that is, the first step to this process is we have to create dynamic DAGs within Airflow, and those DAGs are a set of instructions that tell Airflow what data sources it needs to use to collect our data, and essentially set up our ability to do statistical analysis. The second step is telling Airflow to actually run these dynamic DAGs. The third step is Airflow actually running the DAGs themselves, where it'll do the processing to collect that data. And the last step, it needs to push that information into the data tool itself. So it's interesting that there's actually a couple steps to communicate with Airflow, because traditionally you could be using XCOM. I have found that using XCOM is reliable, but it doesn't meet the criteria, at least for this specific task, which is, it could be that I'm moving around large amounts of data. XCOM has limitations about the size of data that you can push into it. It's also another abstraction layer that I wanted to avoid. So in this case, I try to simplify that by using a medium that's medium between the data tool and Airflow itself, and that's S3. And then the next slide, I'll go over specifically what that looks like. So the Airflow integration, it happens in 4 different steps. The first step is sending the SQL instructions to Airflow itself. In this case, Airflow is receiving a text file that's SQL-like instructions. It's not so much statistical analysis in the SQL files themselves, but SQL operations that extract the data needed to do statistical analysis. And this is pushed over in just a raw SQL file in S3 that Airflow captures. The next step is to tell Airflow to actually process these DAGs, which is a REST API call from the data tool over to Airflow. This could also be scheduled, but essentially what we're doing is we're setting up Airflow to do some processing, and then we're telling Airflow to actually execute those different steps. And the execution looks like any other kind of DAG. In this case, Airflow would pick up the different dynamic DAGs and do a set of familiar steps, which would be generalized as collecting data from the various data stores. In the case of One Medical, we are an AWS shop. A lot of our data resides in Amazon EMR. So these tasks are typically going to pick up Amazon EMR and then collect that data as result sets, package it up in a JSON, and push those over as pickle files into S3. And lastly, those pickle files will be picked up from the data tool itself. So while this is a bit of a process to get information in and out of our databases and pass through Airflow itself, it's one that we could do in batch operations. It doesn't have to live under the limitations of XCOM, and it's pretty defensible and reliable for us. And so a bit about what we're talking about for testing data. So the premise of the problem is, we want to prevent analysts from seeing bad data. And so we want to build this tool to find that data before it goes to analysts. And so for that, we have tests that look at the data that's being processed and tell us whether or not that data fails a test or passes a test. And so in this case, just for the context of what this tool does for testing, the first step for testing is, you define an agnostic test. Let's say, analyze all values of a time series, and it must be within X standard deviations of the mean. The second part of that process is we have to apply this test. And so in this example, let's say that, using our new test, we set a set threshold to 3 standard deviations, and using the table of patients with the column systolic blood pressure for the most recent 90 days, our test is essentially going to be look for all patients and count the number of errors where these blood pressure readings fall outside of 99.99% of normal. And so the next part of this step is, we're going to rely on the data tool and the Airflow to do all the processing and do our statistical analysis. And the end result is user is going to get some results in the data tool that's going to look like this. In this case, this is a test that we've seen that's passed. I think this is significant just for seeing that there's actually results that are coming back from Airflow. And these operations could be done in bulk. And in the case of the DAD tool, it queues up operations in the category of thousands of tests. And this is set up in such a way that if any of those thousands of tests fail, the user sees that they fail and they can navigate those things and do those investigations. So, requirements review to see what we've accomplished here. Now, we need to detect abnormal data on that. We need to scale to thousands of tables and columns. We've done that. And then the cost to minimize the tool is accomplished simply by leveraging Airflow. I would say the development cost to create this tool was probably decreased in the range of maybe 25% of time was saved just by using Airflow itself. So conclusions. So complexity of the Airflow is hidden from the users, meaning that any user of this tool doesn't know that Airflow is actually doing most of the data processing behind the scenes. Using Airflow for part of the backend processing of the data tool significantly decreased the development time. And this case, I think there's considerable savings in the orders of magnitude of maybe 25% for the cost to develop this tool was saved. Because Airflow was already actively used at One Medical, desirable features already available in Airflow could be made available directly to the tool itself. And lastly, time that it would have been spent building features in Airflow were instead repurposed to improve the data tool, which is to say, I didn't have to build parallelism into the data tool. I can just lean on Airflow to do that itself. So some of the features that were incorporated into the data tool to decrease the development cost. No need to manage database authentication. That's already done within Airflow. Databases configured in Airflow are immediately available to the data tool itself. Parallelism is already managed by Airflow, so that's yet another thing that we don't have to manage within the data tool, as well as throttling, so we don't have to punish our databases. And since Airflow already passed our security audit, at least in the case of One Medical, this is really true, is that minimal effort was needed to get approval to leverage Airflow in the data tool. So some answers to common questions. Why not use XCOM? I initially tried to use XCOM, and the limitations about how much data could be pushed through XCOM is something that I was beginning to have issues with. But by going through the S3 route, it's stateful, it's fault tolerant, and I think it's something that's, at least for this case, it makes sense. And lastly, is the data tool open source? Right now, it's not. I'm currently working towards that goal. Development was completed at the end of last year, and due to COVID, a lot of our priorities are being shifted around. So we're all hopeful that we can address these COVID priorities, get through this challenge, and then I want to revisit this goal. And that's it. Thanks.
Okay, thank you, Blaine. That was really interesting to see how the Airflow is used in One Medical. I have a few questions. First is related to the last thing about the XCOM, because in Airflow 2.0 there is going to be a customizable XCOM backend. And do you think it can help you?
I knew that was going to be the first question, and the answer is probably.
Okay.
I haven't played with version 2.0 yet, but I was pretty excited when I saw that new feature was being released.
Good to hear that. The other question is, what schedule do you use for the DAD DAGs? Like, how often do you run them?
Yeah, it's set for a cron job, so they run daily. And with the REST API, you can have it run on demand. Like the user could click play and then kick off the DAG itself. So it depends on what you're trying to solve for. One Medical, we do a lot of daily batches, simply because we accumulate a lot of health information. And so we kind of have the luxury of needing only to run many of our jobs once per day. So it's kind of convenient, but you could tune that up if you'd like.
Okay. How do users input their tests, and how do you translate those into tasks, like custom operators?
Yeah,
Sorry, we can hear you for a moment.
the answer is pretty long. Okay, okay, that's a good question. And I'll try and be brief. Is that that'd be a longer. I mean, a good answer require more time than I think we have. But generally speaking, if a user wants to introduce a new test, it's as simple as adding a class file that could be a couple lines of code. The tests are set up such that they could be templated, so you could reuse other tests. And the UI will pick up that test, and then it's a matter of the user telling these tests to be applied to like a table or a column or a database of every table and every column in that database.
Okay, and
So
the second part was about the operators. Which Airflow operators do you use to perform the action?
yeah, Python operators. I mean, that's it.
So the I-31 is also in your interest.
Yes, it is. Yes. So
Okay.
yeah, the handshake between the DAD tool and Airflow is pretty primitive, and I did that in such a way because I didn't want to complicate it.
Fully understand that. Okay, we have another question, and is are there SQL files version control?
No, um, no, they are not. However, they are saved, and so at no point is any of the data overwritten. Um, I suppose you can go back in history and reference those SQL files that are being passed to the system.
Okay.
So the answer is it depends.